Assalamualaikum and hi, we are from Group 8 want to present about traffic flows using Gauss-Jordan elimination method.
Assalamualaikum and hi. My name is Nur Ain Fariha binti Fairul Azhar and my metric number is 265549. I will present about introduction and objective. First is the introduction. Traffic flow in mathematics is the study of interactions between ridden vehicles, drivers, and even road infrastructure. Roads are the most important means of land communication in Malaysia. The importance of roads is to connect one destination with another, which will facilitate the movement of people to go somewhere smoothly. To ensure a smooth journey, the road or traffic built must meet the specification and the point of conflict that will occur, especially at intersections. This traffic problem is one of the problems of urban society. Generally, traffic problems occur due to the concentration of vehicles on the road due to the increase in the number of vehicles that exceed the capacity of the road. Traffic flow patterns is very influential in determining the density of vehicles in the city. A good traffic patterns will reduce the reduced vehicle density. Therefore, a way is needed to create a traffic patterns that effective to solve this problem. Linear algebra is used to solve problems that occur in the flow of traffic, especially at intersections, and we use traffic flow in Simpang Ampat, Penang, Malaysia, as shown in the diagram below. This is the diagram of Simpang Ampat, Penang, Malaysia, and its traffic flows. Next is objective. Next is the objective. Our objective for this assignment is to understand and improve the optimal road network system with effective traffic movement at Simpang Ampat, and also to minimize the problem of traffic congestion at Simpang Ampat. That's all for my part. Thank you.
Assalamualaikum and hi, my name is Sharima binti Ibrahim. Metric number is 271995. For my part, I will be presenting Gauss-Jordan and mathematical model.
Gauss-Jordan.
In this study, we also use Gauss-Jordan elimination method. The Gauss-Jordan elimination method is an algorithm to solve a linear system of equations by representing it as an augmented matrix, reducing it using row operation, and expressing the system in reduced row echelon form to find the values of variables. This method also can be used to find the inverse of invertible matrix. The main goal of Gauss-Jordan eliminations is to represent a system of linear equations in an augmented matrix form, then performing the three row operations on it until the reduced row echelon form is achieved.
Next is mathematical model.
A system of linear equations was used to analyze the flow of traffic for a network of 4 one-way streets in Simpang Ampat, Penang. The pioneering work done by Gareth Williams on traffic flow has led to greater understanding of this research. the variables and represent the flow of traffic between the four intersections in the network. The data was obtained by counting the number of vehicles that travel around the four one-way streets between the hours of 6 a.m. to 10 p.m. and 2 p.m. to 6 p.m. during the midweek peak traffic hours. The arrows in the diagram indicate the direction of flow of traffic in and out of the network that is measured in terms of number of vehicles per hour. The diagram below describes the four one-way streets in Simpang Ampat under study in the model.
Hi, my name is Farah Azumiti Master. My matric number is 264243. Okay, for my part, I will explain about model assumption and discussion for this project. Okay, for model assumption. Okay, for the following assumption we make in order to ensure the smooth flow of the traffic. First, vehicle entering each intersection should always be equal to the number of vehicles leaving the intersection. Second, the street must all be one way with the arrows indicating the direction of traffic flows. So based on the diagram in the previous slide, we construct system of equation for this model as into four intersections, which is intersection A, B, C, and D. And then we have traffic in and traffic out. So we write the system of linear equation as follows. X plus y equal to 431, x plus w equal to 55, x z plus w equal to 340, and y plus z equal to 516. And then we use the Gauss-Jordan elimination method to solve the system of equation. The augmented matrix and reduced row echelon form of the above term system as follows. After we row operation, we got these answers and we rewrite the answer into a system of equation and then expressing each leading variable in terms of the remaining variable, and then we had x equal to negative w plus 255, y equal w plus 176, z equal negative w plus 340. And then if we take a construction limit on Tasik Mutiara Street, which is route W, to be 100 vehicle per hours, and then the value will be x equal to 155 vehicle per hours, y equal to 276 vehicle per hours, and z equal to 240 vehicle per hours. Okay, for discussion for this project, we discussed that the system of this modeling equation has many solutions, therefore many traffic flow are possible. So, as a driver has a certain amount of choice at the intersection due to the nature of this model. Considering the stretch of road DC, is it desirable to have small traffic flow Z as quadruple along the stretch of road? The flow can be therefore be controlled along the various branches using traffic lights. According to this model, the third equation in this system shows that Z will be a minimum when W is as large as possible. If it does not exist 340, the largest value W can be assumed without causing negative value of X, or Y is 255. Thus, the smaller value of W is 85. Any route work on Tasik Mutiara Street to Bukit Tamu Street should allow for traffic volume at least 85 vehicles per hour. Therefore, to keep the traffic flowing 240 vehicles per hour must be routed between route D and route C. 155 vehicles per hour between route A and route B, and 276 vehicles per hour between the intersection of route A and route D. Okay, that's all for this discussion.
Hi, my name is Nurul Sawani binti Masri, metric number 264113, and I would like to present the conclusion and the recommendation. Conclusion. We have established that traffic congestion at the four one-way street linking Simpang Empat Street, Bukit Tamu Street and Tasik Mutiara Street can be minimized if any route work on Tasik Mutiara Street to Bukit Tamu Street should allow for traffic volume of at least 85 vehicles per hour. Therefore, to keep the traffic flowing, 240 vehicles per hour must be routed between D and C, 155 vehicles per hour between A and B, and 276 vehicles per hour between the intersections A and D, respectively. This Course-Jordan elimination method helps reduce the risk of accidents in the area. Lastly, recommendation. To reduce the impact of traffic congestion and ensure the free flow of traffic in Simpang Empat, we make the following recommendations to stakeholders in Simpang Empat, such as provide exclusive lanes for public transport, use regulations and traffic engineers to control the traffic, and ensure the use of innovative ideas to reduce traffic impacts on public transports. That's all from us. Thank you for watching.